When installing a 30 kV amps 3-phase transformer to step 240 volts down to 220 volts for a new CNC machine, it's crucial to understand the grounding requirements. Specifically, the question arises whether it is necessary to bond the X4 terminal on the secondary side to the grounding conductor at the transformer, even if the neutral isn't being used. The answer is yes, it is generally required to bond the X4 terminal, which is the neutral terminal, to the grounding conductor at the transformer. The primary reason for this requirement is to provide a safe and effective path for fault currents. When the transformer is connected to a 3-phase, 3-wire source, as described, the neutral terminal, X4, is connected to the neutral conductor of the source. This connection establishes a low impedance path for fault currents to flow back to the source. Without this bond, a ground fault could cause the transformer case and other exposed metallic parts to become energized, posing a significant electrical shock hazard. The bond ensures that these parts are kept at ground potential. The National Electrical Code, or NEC, provides detailed guidelines for grounding and bonding of electrical systems, including transformers. Proper grounding and bonding are essential for personnel safety and for protecting equipment from damage. The grounding conductor, also known as the equipment grounding conductor or EGC, provides a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. The NEC specifies the size and type of grounding conductor required for different transformer sizes and applications. Typically, a copper conductor is used for grounding, although other materials are permitted under certain circumstances. There are a few exceptions to the requirement to bond the X4 terminal to the grounding conductor, but these are typically limited to specific industrial settings. One exception might apply where the transformer is installed in a separate enclosure and the grounding conductor is not readily accessible. In such cases, it may be permissible to omit the bond between the X4 terminal and the grounding conductor. However, it's important to emphasize that these exceptions are only applicable in very specific circumstances and should not be applied to general installations. It is always best practice to consult with a qualified electrical engineer or inspector to determine the appropriate grounding requirements for a particular application. Even in situations where an exception might seem applicable, a thorough risk assessment should be conducted to ensure that the absence of the bond does not compromise safety. Omitting the bond between the X4 terminal and the grounding conductor can increase the risk of electrical shock and equipment damage. In general, it is always a good practice to bond the X4 terminal of a transformer to the grounding conductor, regardless of whether or not the neutral is being used. This bond provides an important safety feature by ensuring that fault currents are properly grounded and that the transformer case and other exposed metallic parts are at ground potential. Proper grounding and bonding techniques are vital for the safe and reliable operation of any electrical system, especially those involving transformers and CNC machines. CNC machines often have sensitive electronic components that can be damaged by voltage surges or ground faults. Therefore, it is essential to ensure that the grounding system is properly designed and installed to protect these components. The grounding conductor should be connected to a grounding electrode system, which typically consists of one or more ground rods, ground plates, or other approved grounding electrodes. The grounding electrode system provides a connection to the earth, which helps to dissipate fault currents and maintain a stable ground potential. The size and type of grounding electrode required will depend on the size of the transformer and the soil conditions at the installation site. The NEC provides detailed requirements for grounding electrode systems, including the minimum size and type of grounding electrodes, as well as the methods for connecting the grounding conductor to the grounding electrodes. In addition to bonding the X4 terminal to the grounding conductor, it's also important to ensure that the transformer case and other exposed metallic parts are properly bonded to the grounding system. This can be achieved by connecting a bonding jumper between the transformer case and the grounding conductor. The bonding jumper should be sized according to the NEC requirements and should be securely connected to both the transformer case and the grounding conductor. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. grounding connections can become loose or corroded over time, which can compromise the integrity of the grounding system. Therefore, it is important to periodically inspect all grounding connections and make any necessary repairs or replacements. It is also important to test the grounding system to verify that it is functioning properly. This can be done using a ground resistance tester, which measures the resistance of the grounding system to earth. The measured resistance should be within the limits specified by the NEC. When working with electrical systems, it's crucial to follow all applicable safety precautions. Always de-energize the circuit before working on any electrical equipment and use appropriate personal protective equipment, such as gloves and eye protection. If you are not qualified to work on electrical systems, consult with a qualified electrician. Incorrect grounding and bonding can have serious consequences, including electrical shock, fire, and equipment damage. Therefore, it is essential to understand the NEC requirements for grounding and bonding and to follow them carefully. By properly grounding and bonding the transformer and other electrical equipment, you can help to ensure the safety and reliability of the electrical system and protect personnel and equipment from harm. Remember that this explanation is for general informational purposes only and does not constitute professional electrical advice. Always consult with a qualified electrical engineer or inspector to determine the specific grounding requirements for your application. The NEC is a complex and comprehensive document, and it is important to understand the applicable requirements before working on any electrical system. By following the NEC guidelines and best practices, you can help to ensure the safe and reliable operation of electrical equipment and protect personnel from electrical hazards. The installation of a 30 kV amps three-phase transformer requires careful consideration of several factors, including the voltage requirements of the CNC machine, the available power supply, and the grounding and bonding requirements. By properly planning and executing the installation, you can ensure that the CNC machine operates safely and efficiently. Grounding is not only a safety measure, it is also a functional requirement for many electronic devices. Proper grounding can help to reduce electrical noise and improve the performance of sensitive electronic equipment. Therefore, it's important to design the grounding system to meet the specific needs of the CNC machine and other connected equipment. In addition to grounding, bonding is also an important consideration. Bonding refers to the connection of all non-current carrying metallic parts to the grounding system. This includes the transformer case, metal conduits, and other metallic enclosures. Bonding helps to create a low impedance path for fault currents and ensures that all exposed metallic parts are at ground potential. The NEC specifies the requirements for bonding electrical equipment, including the size and type of bonding conductors. It's important to follow these requirements carefully to ensure that the bonding system is effective. The bonding conductor should be connected to the grounding electrode system and to all exposed metallic parts of the electrical equipment. This creates a network of interconnected conductors that provides a low impedance path for fault currents. Regular inspection and maintenance of the bonding system are also important. Bonding connections can become loose or corroded over time, which can compromise the integrity of the bonding system. Therefore, it is important to periodically inspect all bonding connections and make any necessary repairs or replacements. It is also important to ensure that all metallic parts are properly bonded together. This can be done by using bonding jumpers or other approved bonding methods. The goal is to create a continuous electrical path between all metallic parts and the grounding system. When installing the transformer, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide specific guidance on how to install the transformer safely and effectively. It is also important to consult with a qualified electrical engineer or inspector to ensure that the installation meets all applicable codes and standards. The installation of a transformer can be a complex and potentially hazardous task. Therefore, it is important to take all necessary safety precautions and to follow the manufacturer's instructions carefully. By properly installing the transformer and grounding and bonding the electrical system, you can help to ensure the safe and reliable operation of the CNC machine and other connected equipment. Understanding the role of the X4 terminal in a three-phase transformer is paramount for ensuring electrical safety and proper system functionality. The X4 terminal, representing the neutral point of the transformer's secondary winding, plays a critical role in establishing a reference point for voltage and providing a return path for unbalanced currents. Even in applications where the neutral conductor is not explicitly utilized for load connection, such as in a three-phase, three-wire system powering a CNC machine, the proper bonding of the X4 terminal to the grounding system remains a crucial safety measure. The primary reason for this requirement lies in the need to create a low impedance path for fault currents. In the event of an insulation failure or other electrical fault within the transformer or connected equipment, a fault current will flow from the energized conductor to ground. If the X4 terminal is not properly bonded to the grounding system, this fault current may not have a clear path back to the source. This can result in elevated voltage levels on the transformer enclosure and other metallic parts, posing a significant electrical shock hazard to personnel. Furthermore, the absence of a proper ground fault path can impede the operation of overcurrent protection devices, such as circuit breakers or fuses. These devices are designed to interrupt the flow of current in the event of a fault, thereby preventing damage to equipment and minimizing the risk of electrical shock. However, if the fault current is not of sufficient magnitude due to a high impedance ground path, the overcurrent protection device may not trip, leaving the fault unaddressed and increasing the risk of a serious electrical incident. The National Electrical Code, or NEC, provides comprehensive guidelines for grounding and bonding electrical systems, including transformers. These guidelines are based on established engineering principles and aim to ensure the safety of electrical installations. The NEC mandates the bonding of the transformer's neutral point, represented by the X4 terminal, to the grounding electrode system, regardless of whether the neutral conductor is used for load connection. This requirement is rooted in the fundamental principle of creating a low impedance ground fault path to facilitate the rapid clearing of faults and minimize the risk of electrical shock. While there may be limited exceptions to this requirement in specific industrial settings, these exceptions are typically subject to stringent conditions and should only be applied under the guidance of qualified electrical professionals. The decision to deviate from the standard grounding practices outlined in the NEC should be based on a thorough risk assessment and a comprehensive understanding of the potential consequences. In most cases, the benefits of bonding the X4 terminal to the grounding system far outweigh any perceived advantages of omitting this connection. The peace of mind that comes with knowing that the electrical system is properly grounded and bonded is invaluable. In addition to ensuring electrical safety, proper grounding and bonding can also improve the performance and reliability of electrical equipment. A well-designed grounding system can help to minimize electrical noise and interference, which can be particularly important in sensitive electronic equipment such as CNC machines. Electrical noise can disrupt the operation of electronic circuits, leading to errors, malfunctions, and even damage to equipment. By providing a low impedance path for noise currents to flow to ground, a properly designed grounding system can help to mitigate these effects. The grounding electrode system serves as the foundation for the entire grounding and bonding system. This system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or underground metallic water pipes that are buried in the earth. The grounding electrodes provide a direct connection to the earth, which serves as a reference point for voltage and helps to dissipate fault currents. The NEC specifies the minimum requirements for grounding electrode systems, including the number, type, and spacing of grounding electrodes. These requirements are designed to ensure that the grounding electrode system is capable of effectively dissipating fault currents and maintaining a stable ground potential. The grounding conductor is used to connect the transformer's X4 terminal to the grounding electrode system. This conductor must be sized appropriately to carry the maximum expected fault current. The NEC provides guidelines for sizing grounding conductors based on the size of the transformer and the available fault current. The grounding conductor should be installed in a manner that minimizes impedance, such as by avoiding sharp bends and long runs. This will help to ensure that fault currents can flow quickly and easily to the grounding electrode system. Bonding jumpers are used to connect the transformer enclosure and other metallic parts to the grounding system. These jumpers must also be sized appropriately to carry the maximum expected fault current. The bonding jumpers should be installed in a manner that provides a low impedance connection between the metallic parts and the grounding system. Regular inspection and maintenance of the grounding and bonding system are essential to ensure its continued effectiveness. Grounding and bonding connections can become loose or corroded over time, which can compromise the integrity of the system. Therefore, it is important to periodically inspect all connections and make any necessary repairs or replacements. In addition to visual inspections, it is also recommended to perform periodic ground resistance testing to verify that the grounding electrode system is functioning properly. Ground resistance testing involves measuring the resistance between the grounding electrode system and a remote earth reference point. The measured resistance should be within the limits specified by the NEC. If the resistance is too high, it may indicate that the grounding electrode system is not functioning properly and needs to be repaired or replaced. In summary, the proper bonding of the X4 terminal to the grounding system is a crucial safety measure that should not be overlooked. This connection provides a low impedance path for fault current, helps to prevent electrical shock, and ensures the proper operation of overcurrent protection devices. By following the NEC guidelines for grounding and bonding, you can help to ensure the safety and reliability of your electrical system.